Welcome everyone. Let's talk about bonding, or what we call chemical bonding. Is this something very hard? Not really, because bonding basically means that you have two atoms that are coming together. Okay? So we have compounds, for example. These compounds are made up of atoms of different elements, right? And we have been referring to the combination of these elements or these atoms as chemical bonds. So chemical bond is basically two atoms coming together. It could be atoms of the same element or atoms of different elements. So we are going to look at the different types of chemical bonds, and then we see what happens when we have these bonds. What nature of compound are we going to get? Okay, so we shall relate chemical bonds to the nature of the chemical compounds that we get as a result of these chemical bonds. Okay, so we shall also look at terms that are usually used in talking about chemical bonds. And this actually is a good image here, where we are having hydrogen atom combining with the chloride atom. Yeah, so a chemical bond is what attaches two atoms together as a union. Okay, so that means actually, and I think the word bonding in English, which to say, you have a very strong bond with John or Jane. What does that usually mean? It means that your friendship is actually very strong. Okay, you have a very strong bond. So you can relate it to this situation. You're saying that the atoms are combined together using a chemical bond. But what is that bond? It's a force of attraction. Okay, that brings these atoms together. Okay, so if there is no force of attraction, then that means that the atoms will be apart. So there should always be something that brings these atoms together. So if you use the example of your friendship, that bond that you have with maybe another person, that bond is happening because you have mutual attraction towards one another. You basically like one another. So it's the same thing with atoms. The atoms like one another. And of course, there are characteristics that make them select the atoms that they can combine with. Just like you have the characteristics of the person that you want to have strong relationships with or strong friendships with. Okay, there are those things that you look out for in such people. So in atoms, that still holds, that you have these atoms combining because either the other atom has what the other likes, or both of them are similar in one way or the other, and that's why they actually belong together. Okay, so usually the key thing is that atoms have to attain what we call the noble gas configuration, which is basically meaning the arrangement of atoms in the amine elements in the outermost shell, okay, or in the outermost energy level. For you to attain, or for the atom to attain the noble gas configuration, it means that they need to have, and they should have 8 here. They should have 8 electrons in the outermost shell. Okay, that is what they ought to have. Okay, so for atoms to be stable, this is the electronic configuration that they need to have, and that's why we call it the noble gas electronic configuration. So if the atoms don't have this configuration, they will tend to either gain electrons or lose electrons to gain this configuration. So that becomes like the ultimate goal. That is what the atoms have to achieve. Okay, so in achieving this configuration, they form bonds in that process. Okay, that's what we need. And these usually, all these elements here are the ones that we call the noble gases. Okay, so they basically have for example, helium has 2 electrons in the outermost shell, but the rest of the noble gases have 8 electrons in the outermost shell. Okay, so what atoms have to achieve is having the 8 electrons in the outermost shell, and that is often what we refer to as the octet rule. The octet rule. Okay, that is what atoms actually have to obey. Okay, so if they have 8 electrons in the outermost shell, then they are stable. So they can attain this stability by getting or losing. So what are the different types of bonds that we shall look at? We shall look at the ionic bond, we shall look at the covalent bond, coordinate bond, and the metallic bond. We shall look at the van der Waals forces, and then the hydrogen bond. Okay, those are the 6 types of bonds that we are going to look at. So an ionic bond, what does it involve? It involves transfer of electron from a metal to a non-metal. The key word, metal to non-metal, and that is electron transfer happening. Okay, so ionic bonds happen between metals and non-metals. Okay, what happens is that the metal gives the electron, and then the non-metal receives it. Okay, so for example, magnesium, let us use the example of sodium here. Sodium has the electronic configuration of 2 to 8 to 1. So for it to have the noble gas configuration, it needs to move from 2 to 8 to 1 to 2 to 8. So that means this one has to be lost. That electron has to be lost. And then who gains it? Chlorine. When chlorine gains it, it becomes, so you have chlorine atom, like that, right? That's the chlorine atom. Now, if it receives an electron, it becomes chloride ion with a negative. Positive, I received an electron. Okay? So when chlorine here, you can see the noble gas, the configuration of a chlorine, it is 2 to 8 to 7. It has to move in a way that increases to 8. So by gaining the electron and becoming chloride, it increases its configuration to 8, and then it becomes stable. So it becomes 2 to 8 to 8, what we basically have here. So this is an ionic bond that is happening because of the attraction between the positively charged sodium ion and negatively charged chloride ion. Remember, the positively charged ions are the ones we call the cation, the cations, and then those that are negatively charged are the ones we call the anions. Okay, so the negative and positive do attract, and that is what we have in ionic bonding. Okay, so sodium loses, becomes stable. Chlorine atom gains the electron, becomes stable. And then the forces of attraction between them, the force of attraction is what we are calling here electrostatic attraction, okay, resulting from the opposite charges, the positive on sodium and then the negative on the chloride ion. So metals and non-metals form ionic bonds. This is because, okay, so we look at the examples of ionic bonds. Magnesium chloride has written like that, has ionic bonds. Sodium chloride, we have seen that, calcium oxide, magnesium oxide. So let's look at the characteristics of these ionic compounds. One is that they exist as ions. Okay, they actually contain ions, not molecules. Okay, so for example, the sodium exists as the sodium ions and then the chloride ions. Okay, and then they can actually conduct electricity. That means that actually they are electrolytes. In their molten state, electricity can go through. Okay, because of the ions that we are having in there. And then they have a high melting point because of these strong bonds that are created with strong forces of attraction. So that means to break them, you need to first have a lot of energy supplied. So high melting points. Still also high boiling points. They are insoluble in organic solvents, but are very soluble in, for example, water. So we move the second type of bonds, the one we call the covalent bonds. The one co usually means working together, cooperation, okay, cooperating, and things like that. So covalent bonds mean that you have electrons that are being shared between the atoms. You bring, I bring, the atoms contribute. Okay, they contribute. So that's why we say they have shared electrons. They share electrons. Okay, so this happens between non-metal atoms. Okay, so the bonds formed in non-metals are called covalent bonds. Okay, so each atom contributes. Okay, that's what we are saying. The aim is still to achieve what we called the noble gas electron configuration. And here we are having hydrogen. Hydrogen exists as a diatomic molecule, meaning that you have two atoms combining together to form a hydrogen molecule. So the bond between one hydrogen atom and another is covalent. Why? Hydrogen is the first element in the periodic table. It has one electron in the outermost shell, and the other atom also looks similar to this. So they will contribute to form, make sure that they have at least two electrons here that are being shared. So you have one contributing and the other contributing. So another hydrogen is contributing this. That's what you have, this bond here. This bond here is consisting of one atom from this and then another atom from this. Okay? So that's what happens. So covalent bonds are in non-metals. So carbon dioxide, water, nitrogen, all those form what we call covalent bonds, and they are of several types. So these covalent bonds can be of different types. We have single covalent bonds. For example, the hydrogen that we have just shown there, where you have one combining with another. Okay, this is a single bond. but you can have double, triple, and also quadruple covalent bonds. Carbon dioxide, here the bond between carbon and oxygen is a double bond. Here we also have double bonds. These dots here are to illustrate the electrons that are around the atom. Okay, triple bond, so nitrogen has 3 bonds between the nitrogen atoms, and then the quadruple covalent bonds. That this also means that you have 4 bonds where each is contributed by the other. Okay, so for all these types, whether double, triple, or quadruple, these all involve sharing. You contribute 2, I contribute 2. You contribute 1, I contribute 1. Okay, that's what happens with covalent bonds. It's about sharing. It's the same thing that happened with the chlorine molecule. Okay, it's about sharing. So when they share, then they attain the electronic configuration of noble gases and they become stable. So that is what happens with chlorine. So we already saw that with chlorine, you have a configuration of this. Okay, so 1 electron is missing to make it having a noble gas configuration. So they basically share. One contributes and the other contributes, like that they have this covalent bond here. So one is from this and another is from that. So you have chlorine. It's like that. Okay. So covalent bonds, they exist as discrete molecules. Hydrogen, chlorine, nitrogen, all those exist as discrete molecules. They exist as molecules. They don't conduct electricity, and then the bond is not very strong. So low melting point, low boiling point, and they are insoluble in water, but insoluble in organic solvents and also non-polar solvents. So we move to the other type, the third type now, what we call the dative or coordinate bonding. So let's look at this type of bonding called metallic bonding. This happens when you have a metal atoms actually combining together because of the forces of attraction between the nuclear attraction and the freely flowing or delocalized electrons. Okay, so this is basically what you have here. You have a metal ion that is positively charged, you already know that. But this metal ion also have they are actually surrounded with electrons that are delocalized. That is to say they are freely moving. Because delocalized means that they are freely moving. So these electrons are being pulled by these metal ions. So that is the force of attraction that is holding them together. And that type of bond is what we call the metallic bond. Okay, so what are the characteristics? The more you have more delocalized electrons, the stronger the bond. Okay, so that means that the strength of the metallic bonds are not the same throughout with all the metals. Okay, we have those metals that have many electrons, which we often call the sea of electrons, and then we have those that have very few delocalized electrons. Their strength will not be the same. So that's why you have some metals which are weaker with the weak metallic bonds, and we have those that have strong metallic bonds. So iron and aluminium have strong metallic bonds, and then for metals like potassium and sodium have weaker metallic bonds because of the few delocalized electrons that are there. So that means that for those that have very strong metallic bonds, their boiling and melting points are going to be higher compared to those with the very weak metallic bonds. Okay, so that means that there is variation in the boiling points for different metals. Okay, and because of the packing of these ions, metal ions, you will have a bigger structure, which we often call the lattice structure. Okay, or lattice, metal lattice. Okay, this make them giant, having high density because the ions are closely packed. Okay, and then we have those that can actually, where the ions have the ability to slide past to one another, while the localized electrons also try to hold them together, making some of these metals actually think that the ones that you can actually mold around, making them ductile and malleable. Okay? So we move to now the additive bonding. Okay? So what is additive bond? It's actually a type of covalent bond. Okay? Why is it a type of covalent bond? Because it also involves sharing electrons. But the unique thing is that those electrons are contributed by one partner or one atom. Okay? One atom contributes. So it is not uniform distribution like we saw earlier on. Okay? So they come from one atom. That's what makes them different. So one is a donor, then one actually accepts. So one is the donor, one is accepts the pair. Okay? So ammonia. Ammonia here is reacting with this hydrogen ion to give you the ammonium ion, which is this. Okay, it's the one here. The electrons here to form the bond are contributed by the ammonium ion. Okay, the ammonia is that contributes the electrons to form the ammonium ion. Take note of that. I think editor will remove that first statement that I had made. Okay, ammonia reacts with hydrogen ions to form ammonium ion. The electrons are coming from the ammonia. Okay, and then the two electrons here are coming from ammonium to form the ammonium ion with a positive, which is this here. So we look at the van der Waals forces, which we can call the molecular bonding. So you have molecules that are basically neutral, but the electrons distribution across this molecule is not uniform throughout. So sometimes you have an end where you have positive end and a more negative end, and as a result you have attraction between these different molecules. Those are the ones we call the van der Waals forces of attraction. Okay, so what are molecules? Actually, one molecule is attracted to the other because of the van der Waals forces. You have positive and negative ends of the same molecule, so they keep attracting one another. They are weaker. Okay, they are weaker than ionic or covalent bonds. Okay, so they only increase in strength with increase in molecule size or mass. So definitely they are not very strong, low melting point, low boiling points. Okay, and this actually allows some substances like iodine to undergo what we call sublimation, which is turning directly from a solid to a gas direct because of different forces. Okay, but of course, as you move down the group, the boiling points are increasing because of the increasing molecular size. The larger the molecular size, the stronger the forces, and that means it increases the boiling and melting points. And then hydrogen bonds, or what we call hydrogen bonding. These are dipole-dipole attraction, where the hydrogen atom is actually attached to a highly electronegative atom. For example, nitrogen, oxygen, and fluorine. When we talk about electronegativity, we are referring to the tendency of an atom to attract electrons or to accept electrons. That is what we call electronegativity. Okay, so in water you have hydrogen bonds between the hydrogen of one water molecule and the hydrogen of another water molecule. Okay, you can see that in water actually we have explained the different bonds in water. We talked about covalent, where you have a bond between nonmetals. We talked about van der Waals forces. We are now also talking about hydrogen bonds. And we have also used water in several instances in that. Okay? So that basically know that the extent to which we actually have different types of bonds in one compound. It's not that a compound will always strictly have one type of bond within it. Okay, so that is a concept I don't want to go into now, but it's something that perhaps you need to note. Okay, so there could be an element of ionic covalent somewhere there, but of course we universally accept that the type of bonding between metals and non-metals are ionic bonds. Between a non-metal and a non-metal covalent bonds. And then we also talked about metallic bonds and then additive bonds. Van der Waals forces and hydrogen bonding, we have brought them in here, but it's not our focus at this level for now. Thank you for listening.